Hello everyone. Today we will try to solve the question of time and work. I will try to explain the concept, the method used to solve the questions. You can use this method to solve any questions of time and work, be it banking examination or railways, but I will mainly focus on SSC combined graduate level examination. You can use any method to solve time and work questions. You can use the fraction method, which you'll find in books, but I will be using the LCM method because fraction method takes time. It is more calculative, calculation is involved, but LCM method will be quicker and it will help you to save some time. And as you know, we are preparing for competitive examination, so every second counts. All right, so let's begin with our first question. Our question says A and B can complete a work in 30 days and 20 days respectively. In how many days they together complete the work? So as I will be using the LCM method, in this question we are given A can complete a work in 30 days and B can complete the same work in 20 days. So we will take the LCM of 30 and 20. Our LCM is 60. Now this 60, this is our total work. So 60 work needs to be completed. Uh, 30 and 20 is our time taken. Now if we divide 60 by 30, we get 2, and if we divide 60 by 20, we get 3. Now this 2 is our one day work of A, or we can say 2 is the efficiency of A. If A alone works for a day, then he can complete 2 units of work, and if B works for a day alone, then he can complete 3 units of work in a day. I'll write it for you. This is our efficiency or 1 day work. All right, now if A and B, if they together work for a day, then how many units will be done? How much work will they complete? They will complete 2 plus 3, which is 5 units of work. Now our total work is 60. We can call it 60 units, our total work. So in our question, we need to find out how much time will be required to complete 60 units of work if A and B, if they work together. So now 60 divided by 5 will give us 12 days as our answer. Now if you look at this problem, you will find a formula. Now if we the formula is total work is equal to time taken into efficiency. So here if we see 30, which is our time taken, into 2, which is our efficiency, 30 into 2, we get 60 as our total work. So we need to in this question we were told to find how much time was taken by A and B. So time taken will be total work divided by efficiency. All right, let's move on to the second question. The second question is same, only the difference is that C has been added. That means one more person has been added. So in this question we have A, B and C can complete a work in 12 days, 15 days and 20 days respectively. in how much time they together complete the whole work. So here also we will follow the same method. Our same method, that is A completes the work in 12 days, B completes the same work in 15 days, and C completes the same work in 20 days. So as I said, we will take the LCM. The LCM of 12, 15 and 20, it will be 60, which is our total work. Now 60 divided by 12, we get 5. This is our efficiency, 1 day work of A. And if we divide 60 by 15, we get 4, which is B's efficiency, and 60 divided by 20, we get 3, which is C's efficiency. So in this question, we need to find out if the three persons A, B and C, if they together work for a how much time will be required to complete the whole work if they work together. So they will be able to complete how many units of work in a day? 5 plus 4 plus 3, that is 12. So if they together work, then they will require 60 divided by 12 is equal to 5 days. So 5 days will be required. Alright, moving on to next question. The question says A and B can complete a work in 10 and 12 days respectively. A and B start work together, and after 3 days A leaves the work. Then calculate in how many days work will be completed. So A can complete the work in 10 days. B can complete the same work in 12 days. As I said, we will take the LCM. Our LCM will be 60. 60 is our total work. 60 divided by 10, we get 6. 6 is the efficiency of A, 1 day work of A, and 60 divided by 12, we get 5. Now in this question, A and B start work together, and after 3 days A leaves the work. That means A works for only 3 days. So if we see 6 is the efficiency of A, that means if he works alone, he can complete 6 units of work in a day. So if A works for 3 days, he will be able to complete 18 units of work. So 18 completed by A out of 60. Now remaining work is how much? 60 minus 18, which is completed by A, we get 42. Now this 42 is completed by B. That means B starts the work along with A and he completes the whole work. So that so this whole 42 units is completed by B alone, and we know the efficiency of B, which is 5. So 42 divided by 5, we will get 8, 2 by 5 days. So here B begins the work along with A. So if B without stopping, if he works, then he will require 8, 2 by 5 days to complete the whole work. So this is our answer. Alright, moving on to next question. Question number 4. A and B can complete a piece of work in 10 days and 15 days respectively. A and B start work together, and after 2 days A left the work, or A leaves the work. Then calculate in how many days work will be completed. Same question, the same method we will follow. A can complete the work in 10 days, B can complete the work in 15 days. We will take the LCM. Our LCM is 60, which is our total work. So 60 divided by 10, we get 6. 60 divided by 15, we get 4. 6 is the efficiency of A and 4 is the efficiency of B. That means if A alone works for a day, then he can complete 6 units of work. So 4 is the 1 day work of B. Now in this question, A and B start work together, and after 2 days A left the work or leaves the work. So A works for 2 days. So if A completes 6 units of work in a day, in 2 days he will be able to complete 12 units of work, and our total work is 60. Our remaining work will be how much? 60 minus 12, which is 48. So 48 units is the work which is done by B. Now 48 divided by 4. 4 is our efficiency of B. B is 1 day work, so he will able to, so 48 divided by 4 we get 12. So that means B works for how many days? 12 days. Starting with A, he will require 12 days to complete the whole work. So 12 is our answer. Alright, moving on to next question. Question number 5. A and B can complete a work in 10 and 15 days respectively. A and B started working together, but after some time A left the work, and the whole work will complete in 9 days. Then calculate after how much time A left the work. Same question, they have just put it in a different way. So we'll quickly take the LCM. A works for A can complete it in 10 days. B completes the work in 15 days. We take the LCM, which is 60. This is our total work. 60 divided by 10, 6. 60 divided by 15, we get 4. Now in this question, A left the work after some time. So we need to find out when did A leave the work. Now the whole work will complete in 9 days. That means B works for complete 9 days from the start till end. So if B works for 9 days, he will be completing how many units of work? 4 9s are 36 units of work is completed by B, and the remaining work is completed by A. So 60 is the total work minus 36 work is done by B. So we get 24 units of work which is remaining, and this 24 units of work is done by A. Now the efficiency of A is 6. So if we divide 24 by 6, we get 4 days. That means A leaves the work after 4 days. A from the start he works for 4 days, and after that he leaves the work. So 4 is our answer. Alright, moving on to next question. It's similar to question number 5. A and B can complete a work in 20 days and 30 days respectively. We will take the LCM. A works for 20 days and B can complete the work in 30 days. We will take the LCM. 60 is our total work. 60 divided by 20, we get 3. 60 divided by 30, we get 2. 3 is the efficiency of A and 2 is the efficiency of B. So in our question we have A and B starts working together, but after some time B left the work, and the whole work is completed in 16 days. Then calculate after how much time B left the work. So B works from beginning till end. So efficiency of B is 2. So if he works for 16 days, he will be completing 32 units of work out of 60. Our remaining work is how much? 60 minus 32, which is 28. Now 28 work. Oh, I'm sorry. Here A works for 16 days. Alright. So A works for 16 days. So 48 work is completed by A. Now remaining work is how much? 60 minus 48 is equal to 12. Now 12 units of work needs to be done by B. Efficiency of B is 2. So if we divide 12 by 2, we get 6. So B works for 6 days, and after 6 days he leaves the work. So 6 is our answer. Alright, next question we have. A and B can complete a work in 20 and 30 days. A and B started working together, but after some time B left the work, and the rest work will complete by A, and the rest work is completed by A in next 10 days. Then calculate after how much time B left the work. So in this question, A completes the work in 20 days, B completes the same work in 30. We will take the LCM, which is our total work. We will get the efficiency by dividing 60. We will divide 60 by 20, we get 3, and 2 is the efficiency of B. Now the question says that A and B started working together, but after some time B left the work, and the rest work is completed by A in next 10 days. So if A works for 10 days alone, then he will be able to complete 30 units of work. So our remaining work is how much? Our remaining work will be 60 total work minus 30 is equal to 30. Now this 30 units of work is done by A and B together. So if we see 3 is the efficiency of A, 2 is the efficiency of B. If we plus, we get 5. So 5 units of work is done by A and B if they work together in a day. So 30 divided by 5 is equal to 6. So the question is, then calculate after how much time B left the work. So B left the work after 6 days. Alright, moving on to next question. Question number 8. 2 men can build a wall in 15 and 20 hours respectively, but if they work together, they use 280 less bricks per hour and build a wall in 12 hours. Find the number of bricks in the wall. Alright, we will take the LCM. Here it says A can build a wall in 15 hours and B can build the same wall in 20 hours. We will take the LCM, which is our total work, 60 units. 60 divided by 15, 4. 60 divided by 23. This is the efficiency of A and B, 4 plus 3. So if A and B, if they work together, they will be able to complete 7 units of work per hour. Now in this question, we have, if they work together, they use 280 less bricks per hour and build a wall in 12 hours. So they build a wall in 12 hours. That means 60 divided by 12, we get 5. So 5 units of work is done by A and B working together. So that means their efficiency has gone down as per the question. Originally they were doing 7 units, but now according to question they are able to complete 5 units of work. So their efficiency has gone down from 7 to 5. That means 2 units. Now as their efficiency has gone down, because of this they are using 280 less bricks per hour. So this 2 units is representing our 280 bricks. So our 1 unit will represent how much? How many bricks? 140 bricks. Now 1 unit represents 140 bricks. Our total work is 60. So 60 unit will represent 6 into 140, which is 8400 bricks. So our total work is 8400 bricks. So in this question, find the number of bricks in the wall. So the number of bricks in the wall is 8400. Moving on to next question. The next question is similar to the previous one. two men can build a wall in 9 and 10 hours respectively, but if they work together they use 10 bricks less per hour and build a wall in 5 hours. Then find the number of bricks in the wall. Same question. First person, let's take A. Second person, let's take B. 9 hours, 10 hours. If you take the LCM, 90. So 10 is the efficiency of A and 9 is the efficiency of B. Now originally they are working, if they work together, they are able to complete 19 units of work per hour. But as per the question, it says if they together work, they can complete the whole work in 5 hours. So their efficiency is how much? Their efficiency will be 18. So originally we have the efficiency is 19, but according to question we are getting the efficiency we get the efficiency of 18. So 1 unit is less. Now because of this, as their efficiency has gone down, they are able to use 10 bricks less per hour. Okay, so 1 unit is representing 10 bricks. So 90 unit will represent how much? 90 unit will represent 900. 90 into 10 is equal to 900 bricks. So 900 bricks is our answer. Alright, question number 10. Two candles of same height can burn completely in 4 hours and 6 hours respectively if both start burning together at same time with their respective constant speed. Then calculate after how much time the ratio of their height will become 2:3. So in this question we have two candles. Let's suppose A and B. Two candles. A takes 4 hours to burn completely and B takes 6 hours to burn completely. We will take the LCM, which is 12. Now if 12 divided by 4 we get 3 and 12 divided by 6 we get 2. Now this 12, let's suppose this is our total work, or let's say in this question let's say total distance. Now if a candle burns completely, that means he will be starting from the top and it will finish till the end. So let's take it as total distance. Now this 3 efficiency will become our speed, and we know the formula of time and distance. Total distance is equal to speed into time. So in this question we need to find how much time is required for the two candles to be in the ratio which is 2:3. So let's say T hours is taken. T hours or time is taken. So in T hours, the first candle A, it will be moving a distance of how much? 3 into T, that is 3T. And the second candle, if it burns for how much? T hours, then it will be moving a distance of 2 into T. So as per the question, 12 minus 3T and 12 minus 2T is equal to, the ratio will be how much? The ratio is 2:3. Okay, so I think you have got the concept here. 12 is the total distance. The time required is T. We have assumed that T hours has been taken by both. So in T hours, the first candle will be it will burn 3t distance, and the second candle B with a speed of 2, it will burn 2t distance, and the ratio which has been given to us, that is 2:3. Now if we solve this equation, we will get 36 minus 90 is equal to 24 minus 40, and if we t is equal to 12. Okay, so we'll get the value of t, which is 12 by 5. So time taken is 12 by 5. If we write it in minutes or hours, it will be 2 hours 24 minutes. So this is our answer. So after so if both the candles A and B, if they burn together for how many hours? For 2 hours 24 minutes, then the ratio of their height which will remain will be 2:3.